Florida's geological crisis is intensifying, and the foundation beneath Miami is breaking apart right now. This isn't a hurricane. This isn't a storm surge. The ground under Florida is disappearing, as if someone pulled the plug on the coastline. Imagine waking up to find your beach completely gone. Not gradually, overnight. A massive void opens beneath the water, and the sand begins sliding into it like it's being pulled down a drain. Tourists rush out of hotels in their pajamas. Sirens blare. Entire sections of coastline are shut down because officials cannot predict what will collapse next. But the detail that has scientists deeply alarmed is this. Black tar is washing onto the shore, and tests confirm it is not from an oil spill. It is ancient material trapped underground for thousands of years, now leaking through fractures that were never supposed to exist. Then something even stranger occurs. Florida begins to experience earthquakes. So what is actually failing beneath Miami? Just scattered sinkholes, or a hidden underground cavern system capable of turning an entire coastline into a collapse zone? December 18th, 6:47 a.m. Eastern Standard Time. A Coast Guard patrol vessel moves across calm water near Deerfield Beach when the depth finder displays a reading that defies logic. 40 feet deep, while official charts list 12. Lieutenant Commander James Walsh radios the coordinates twice, assuming a malfunction. It isn't. Within minutes, aerial surveillance confirms the unimaginable. A sinkhole nearly 300 feet wide has opened on the ocean floor overnight while Florida slept. At 7:23 a.m., a second void tears open near Pompano Beach. This one is even larger, 450 feet across. From the shoreline, tourists filming the sunrise capture the moment the sand beneath them begins sliding toward the sea. The beach doesn't erode, it sinks. Sirens echo across Broward County. Hotel guests rush outside in their pajamas, clutching children and phone chargers, uncertain whether the ground will still exist tomorrow. Lifeguard towers begin to tilt as the seafloor pulls sand outward, like a drain opening beneath paradise. By 8:15 a.m., a third sinkhole rips through the seabed near Boca Raton. The Florida Department of Environmental Protection shifts into full crisis mode. Director Amanda Torres coordinates with 15 county emergency offices as reports pour in faster than teams can respond. NOAA aircraft sweep along the coastline, scanning with sonar. The first images send a wave of dread through every command center. These sinkholes are not isolated events. They are connected. An underground network is collapsing in real time. At 9 a.m., sharp officials close 47 miles of coastline from Port Everglades to Palm Beach. The Coast Guard establishes no-go zones 2 miles offshore. Deputies block beach access as confused crowds demand answers. The numbers keep rising. 12,000 tourists displaced. 8 major resorts evacuated. And beneath the calm blue water, more voids are forming. The coast isn't eroding, it's collapsing. By mid-morning, the lockdown spreads like a shock wave. At exactly 9 a.m., authorities seal off 47 miles of coastline. From Port Everglades to Palm Beach, yellow tape flaps in the wind where beach umbrellas stood just hours earlier. Patrol boats form a moving barricade 2m offshore. No swimmers, no surfers, no boats allowed near the collapsed zone. Crowds gather behind police lines, staring at water that looks perfectly calm. But beneath that flat blue surface, sonar scans reveal something terrifying. The ocean floor is no longer solid. It is breaking apart. 12,000 tourists are forced out of beachfront hotels before noon. Major resorts shut down completely. Suitcases roll across sidewalks as families search for rides inland. Emergency shelters open in Fort Lauderdale and West Palm Beach, filling faster than staff can process names. Lunchtime, some shelters report standing room only. At 11:42 a.m., NOAA's Disaster Response Division releases updated aerial imaging. What officials feared most is confirmed. 23 separate underwater sinkholes scar the seafloor across 15 square miles. Some are newly formed, others are expanding hour by hour. Dr. Marcus Reynolds of the United States Geological Survey studies the images with visible alarm. He calls it an unprecedented collapse event, unlike anything in Florida's recorded history. His voice stays calm, but the numbers do not. Preliminary damage estimates already exceed $2.3 billion, and the count is climbing. Engineers warn that beaches are only the beginning. The same limestone platform under the seafloor stretches beneath coastal highways, neighborhoods, and high-rise towers. If the collapse network continues spreading, foundations built on what seemed like solid ground could begin to shift. Officials try to reassure the public, but behind closed doors, one question dominates every briefing. How far does the underground failure really go? Florida sits on a massive slab of limestone. From the surface, it feels solid, but limestone is porous, almost like a sponge made of rock. And right now, that sponge is dissolving from below. Rainwater mixes with carbon dioxide in the air and forms a weak acid. Normally, that acid slowly eats away at limestone over hundreds or even thousands of years. But something has changed. Salt water from rising seas is pushing farther inland. The chemical reaction is speeding up. What once took centuries is now happening in months. Dr. Sarah Chen with the United States Geological Survey explains it in simple terms. The rock is being eaten alive, and the process is accelerating faster than any geological model predicted. Emergency sonar mapping reveals what lies beneath the beaches. A massive network of underground caverns stretches from Miami to Jupiter. Some chambers are 200 foot tall. Some run for miles. The images look less like solid ground and more like Swiss cheese. University of Florida researchers led by Dr. James Martinez build three-dimensional models of the coastline's foundation. The results are disturbing. Entire communities sit above hollowed-out chambers that were never mapped before. The first collapse exposed them. Multiple stressors are hitting at once. Sea levels rise a little more each year, adding pressure to already weakened rock. Saltwater intrusion weakens limestone 40% faster than records from the last century. Temperature swings cause expansion and contraction that fracture rock even more. Dr. Lisa Wong at Scripps calls it a perfect storm for geological failure. The numbers tell the real story. Florida once averaged 2 to 3 sinkholes per year statewide. Now collapse rates approach 12 per week. In the affected zone, monitoring stations pick up acoustic anomalies, sounds of rock cracking, underwater in real time. The ground beneath Paradise is not stable. It is breaking. At 7:15 that same morning, lifeguard Marcus Johnson steps onto Deerfield Beach and freezes. The sand is coated in thick black tar. Not a few patches. Solid, sticky lines stretching down the shoreline as far as he can see. Within hours, cleanup crews collect more than 2,400 pounds of the material across a 12 millimeters stretch from Port Everglades to Pompo Beach. The first fear is an oil spill. But 6 hours later, the Florida Department of Environmental Protection rules petroleum out. This isn't crude oil. It's something far older. Angela Martinez, a marine geologist at the University of Miami, studies the samples under powerful microscopes. The lab results send a shock through the scientific community. Tar contains ancient organic matter that remained trapped inside limestone for thousands of years. Carbon dating places its age between 15,000 and 50,000 years. Material from the last ice age is now appearing on present-day beaches. The link can no longer be ignored. Maps showing where tar balls appear align almost perfectly with known offshore collapse zones. Wherever the seafloor drops, ancient layers are exposed. Fractures that should have remained sealed have turned into open channels to buried history. Environmental teams extend swimming bans across 31 miles of coastline. Wildlife damage rises rapidly. 47 sea turtles show evidence of tar ingestion. 12 dolphins suffer from severe respiratory distress. Rescue centers report being overwhelmed within 48 hours. Then another warning emerges. Methane levels surge in certain collapse areas, suggesting gases trapped deep within fractured rock. Scientists begin referring to the tar balls as a geological warning system. If material buried for tens of thousands of years is reaching the surface now, it indicates fractures stretching deep into the bedrock, hundreds of feet below. The ocean is not simply swallowing sand. It is ripping open layers of earth that were never meant to be exposed again. Maria Martinez stands outside her family restaurant in Pompano Beach, staring at cracks that did not exist the day before. The building had endured hurricanes, floods, and economic downturns. But overnight, thin fractures spread across the walls like spider webs. At 9:47 a.m., a building inspector delivers the decision. The structure is compromised due to ground subsidence. Evacuate immediately. For 18 years, the beachfront restaurant held 3 generations of memories. It is valued at $2.8 million. The insurance policy covers storms and fire. It does not cover ground collapse. Maria packs 3 suitcases and family photographs while her 8-year-old daughter asks when they can return. She has no answer. The destruction is not limited to a single structure. Highway A1A near Deerfield Beach reveals stress fractures that engineers insist did not exist 72 hours earlier. Florida Department of Transportation crews measure 6 inches of subsidence along a 3.2-mile stretch. The road closes without warning. 45,000 daily commuters are forced onto neighborhood streets never designed for that level of traffic. Emergency repair estimates reach $89 million, yet no one can guarantee the ground will stop shifting. Just before midnight, Ocean View Towers, a 22-story high-rise housing 340 residents, reports foundation movement during emergency inspections. At 11:47 p.m., a mandatory evacuation order is issued. Residents are given 2 hours to pack. Essentials. Elevators shut down. Elderly. Tenants descend dark stairwells with help from firefighters. Emergency shelters fill beyond capacity. The Red Cross opens additional facilities across Broward County, but beds run out quickly. Alongside the physical damage, a mental health crisis begins to surface. Children wake from nightmares about the ground disappearing beneath them. Anxiety medication. Prescriptions spike by 340% across coastal counties. For many families, the fear is no longer about storms. It is about the earth itself. December 20th, 2:34 a.m., a magnitude 2.8 earthquake strikes 15 miles offshore. From West Palm Beach, seismographs light up across monitoring stations, and scientists stare at the screens in disbelief. Florida does not have earthquakes. The state sits far from tectonic plate boundaries. It averages 0 significant quakes per year. Yet this month alone, 17 detectable tremors have been recorded across the region. Days earlier, a magnitude 2.5 event rattled near Panama City, the largest in a decade. These are not normal seismic events. Dr. Kevin Torres with the United States Geological Survey explains that the signals do not match traditional tectonic movement. Something else is happening beneath the limestone platform. One theory suggests that as massive sections of rock collapse, the sudden weight shifts send stress waves through the porous foundation. Another proposes that seawater rushing into newly formed voids creates pressure shocks strong enough to register on sensitive instruments. Dr. Rachel Kim at Caltech reviews the data and calls it new territory for earthquake science. The patterns are irregular. The vibrations are constant. Within 48 hours, 40 temporary seismometers are installed along 100 miles of coastline. Real-time data streams to USGS headquarters in Colorado. The sensors detect continuous micro-tremors, faint but persistent, signals that suggest progressive collapse moving through interconnected cave systems. The pattern does not stay still. It advances northward at roughly 3 m per day. Vibrations are reported in Miami. Residents hundreds of miles away describe subtle shaking they have never felt before. Computer simulations run worst-case scenarios. If multiple cavern systems fail at once, events reaching magnitude 4 or even 5 are possible. Florida introduces earthquake preparedness programs for the first time in its history. What once seemed impossible is now being measured, and the ground continues to shift. Limestone does not end at Florida's border. The same porous rock supporting Miami extends north through Georgia, South Carolina, and further along the coast. The Atlantic coastal plain stretches roughly 12,200 miles from Florida to New Jersey. Large portions of this region rest on comparable limestone formations riddled with concealed voids. Within 72 hours of Florida's initial collapse, Georgia's Department of Natural Resources dispatches emergency survey teams to its barrier islands. Jekyll Island reports minor subsidence at 3 separate sites. Tybee Island records shoreline erosion increasing beyond historical trends. South Carolina's governor calls for immediate federal geological assessments as caution quickly turns into urgency. Survey expands monitoring networks into 6 states. Dr. Michael Torres at Duke University introduces what he calls the domino effect theory. He presents data showing that pressure changes within Florida's aquifer system could alter groundwater flow patterns across state lines. The aquifer stretches from southern Alabama to South Carolina. When pressure shifts in one region, connected areas feel it. The economic stakes are staggering. Atlantic coast tourism generates $186 billion each year. Coastal real estate across 15 counties totals $2.4 trillion in assessed value. Federal Reserve economists begin modeling scenarios where spreading collapse could trigger a housing crisis worse than 2008. The insurance industry reacts fast. Lloyd's of London reclassifies the Atlantic limestone coast as extreme risk. Private carriers cancel hundreds of thousands of policies. Coastal home sales drop 91% in 2 weeks. Mortgage lenders refuse loans near documented sinkholes. $67 billion in property value vanishes from tax rolls almost overnight. Florida's governor declares a statewide emergency and requests $12 billion in federal relief. The National Guard mobilizes. Congress argues. FEMA strains under back-to-back disasters. 1 week later, 47M remain closed. Seismic tremors continue spreading north. The collapse is no longer just Florida's problem. It may be the Atlantic's. 1 week after the first sinkhole opened, off Deerfield Beach, Florida's coastline looks calm again from a distance. The water is blue. The sun still rises over the Atlantic. Palm trees still sway in the breeze, but the illusion of stability has been shattered. 47 miles of shoreline remain closed to the public. 23 documented sinkholes scar the seafloor across 15 square miles. Damage estimates have climbed past $25 billion and continue rising. 78,000 residents remain displaced from homes that may never be declared safe again. Unlike a hurricane, this disaster does not move on. There is no clear after. The collapse represents an ongoing geological failure with no defined endpoint. Engineers cannot rebuild on ground that continues to shift. Insurance policies specifically exclude the very disaster destroying entire neighborhoods. Government relief funds strain under the weight of back-to-back catastrophes. Beneath Miami skyline, beneath beachfront condos and family-owned restaurants, the limestone foundation that once felt eternal now reveals its fragility. For generations, Florida sold the dream of paradise built on solid ground. That promise is now under question. Scientists continue to analyze data streaming in from sonar scans and seismic monitors. Micro tremors persist. Acoustic sensors still detect the faint cracking of rock underwater. The collapse has slowed in some zones, but it has not stopped. Fractures remain open. Cavern systems remain unstable. The chemistry that dissolves limestone continues quietly, invisibly, every hour of every day. The black tar that washed ashore serves as a reminder that the ground beneath Florida holds layers of ancient history. If material sealed for 50,000 years can suddenly rise to the surface, it means the fractures run deep. What else lies trapped within those layers? What gases, what voids, what unseen weaknesses remain hidden? Beneath miles of coastline, communities have shown resilience. Neighbors open doors to displaced families. Churches organize meal lines. Volunteers help elderly residents move belongings from unstable buildings. The human response has been powerful, but community strength cannot seal fractured bedrock. The economic ripple effects continue to expand. Coastal property markets remain frozen. Tourism numbers collapse. Insurance companies reassess entire regions as uninsurable. Mortgage lenders hesitate. Investors pause. When confidence in the ground itself erodes, the financial system built upon that ground begins to shake, and the concern no longer stops at Florida's border. The same limestone platform stretches north. Other coastal states begin activating monitoring systems for threats they never expected to confront. Geological stability, once assumed along the Atlantic shoreline, is now being closely questioned. The deeper concern extends beyond beaches or buildings. It challenges the idea of permanence itself, the belief that land, unlike weather, does not suddenly vanish. That certainty no longer feels secure. Climate scientists warn that rising sea levels, saltwater intrusion, and shifting temperatures are not short-term anomalies. They represent long-term trends. If these pressures continue accelerating chemical reactions within limestone, the conditions behind Florida's collapse could appear more frequently, not just here, but anywhere porous rock meets encroaching water. 3 nuclear power plants operate in regions now classified as vulnerable. Major ports that sustain national supply chains sit atop similar geological foundations. Military bases, highways, and water systems all rely on stable ground. Beaches may reopen one day. Roads may be repaired. Towers may be reinforced. Yet beneath the surface, the limestone remains porous. It remains chemically reactive. It remains sensitive to pressure and change. For now, visible sinkhole expansion has slowed. Emergency crews continue documenting damage. Scientists keep analyzing patterns that challenge long-standing assumptions about geological stability. Politicians continue debating funding and responsibility. But the most unsettling reality remains simple. The ground that once seemed permanent was never truly permanent. Florida's geological crisis has accelerated beyond expectations. Miami's foundation has already begun to deteriorate in ways that cannot be reversed overnight. And as the Atlantic coastline stretches north across thousands of miles built on similar rock, one question lingers beneath the calm surface of the sea. If the Earth itself can give way without warning, how secure is the future we believe we stand upon?